Nathan Cruz here with CARLSON Software, and in this video I'm going to show you a brief introduction and how to get started in Precision 3D's new drill and blast application for both mine blasting and construction blasting. First thing I'm going to show you is the mine pull down, where we just have a few commands to create the blast patterns. Import a blast pattern either from a CSV or from CARLSON machine control DRL files. You can also export to various CSV formats and to the machine control DRL format as well. And then we have our very detailed both design drill hole report and as drilled reports. Well, I'm going to get started and show you these mine settings. So once you get your P3D drill and blast installed and you have your registration serial number, which should include the Precision 3D Topo plus the blast module in your requests. Essentially, this plugin will become visible once you enter in that serial number. And we're going to get started with just the basic blast pattern settings. So here we have the blast pattern properties. These are just the default properties that we use when you create a blast pattern, and you can change them after the fact. So we have rectangular staggered pattern, your typical row distance, your column distance, vertical dip angle, your dip direction azimuth, which typically changes with each blast, and your default hole depth. This is reasonably important because when we talk about hole loading and putting in different materials, we generally load from the bottom, and when the as drilled holes are not exactly the same depth as the design, then what we vary is the top stemming, and basically we load. When you define your hole loading patterns, we load from the bottom, and I'll show that in just a few minutes. Typical hole diameter. This diameter display scale is basically an exaggeration so that your drill holes are more prominent visually in the 3D environment. So obviously the larger this value is, the larger these tubes are going to appear. Typical high wall distance, and then your minimum top stemming. So in your particular mine or in your construction, if you have a minimum top stemming depth that you need to ensure is covered, when you put in this value and you import your as drilled holes to compare against the design, will tell you whether or not your top stemming is basically violates this tolerance. So if it's less than 5 feet, you're going to get a big red exclamation on top of your drill hole, and you're going to know that there's it's a potential blowout. Powder factor. So we defaulted to explosive weight to blasted volume, but you can also do explosive weight to blasted weight to explosive weight, just the opposite of that ratio. The as-built tolerances, this is also an important bit of settings. So when you re-import your as-drilled holes and compare them to your design, what we're going to do is we're going to show you red exclamations in the 3D window, and we're going to show you special icons in this scenario explorer for any of the holes or rows that basically have tolerance values for either the dip angle or the depth tolerance that violates this particular rule, and we will show those to you. So, and this will vary from mine to mine or from site to site. Loading materials. I think by default you will have info and an empty, but what I've done is I've cleared them out here, and what I'm going to do is just create a couple of these on the fly here. So I know typical info, basically specify the name, whether it's explosive or inert, and then what the specific gravity of that material is so that we can compute the weights based on the volumes, and then the color that you'd like to see in the hole loading pattern. And I'm going to add a couple more. Next I'm going to do drill casting, which is inert, and I'm going to put a specific gravity of 2.5, and I'm going to make that a cyan color. I'll add air. And then black powder. All right, so now I've set up my typical loading materials for the holes, and essentially the only thing that we need to know is whether or not it's an explosive, what the specific gravity is, and the name that you want to call it. And in this way, we can compute the weights, because we typically want to talk about explosives in terms of weight as opposed to depth in a hole. Now I'll click over into the hole loadings tab. In this hole loadings tab, you can define typical hole loads. And in this case, I've just created a new hole loading. I've defined this length to be a typical 100-foot hole loading, and the diameter of 6 inches. Now, changing these values is obviously going to affect the weight of material. And so, what do I mean by that? So, we start with an empty hole, and I'm going to add a material. I'm going to hit OK, so it saves my materials. Go back to hole loadings. I'm going to delete this guy, and I'm going to create a new one. And I'm going to add a material, AMFO. So we're going to start with an explosive load on the bottom. And instead of just specifying some, some depth of, 2 feet of AMFO, you can type in either the thickness of this deck, or you can specify that you want exactly 50 pounds of AMFO at the bottom and hit OK. Next thing we're probably going to do is we're going to add drill castings on top of that. And in this case, if you know that you want to use, let's say approximately 60 feet of drill castings, then we'll go ahead and add that in. And for a secondary deck of AMFO, say we'll put in another 25-pound charge. And I'll click on another add material here. And again, we're telling you that there's still almost 9 feet left on top, and I'm just going to put that back to drill castings. So in the case that, and what I'm also going to do is rename this 100-foot typical. I'm going to go ahead and add another one, and this one I'm going to make a 4-inch hole, and the only material that I'm going to add to it is air, and this is to support pre-splits. And I'm going to rename that And again, if you want to go in and edit either any of these, once you bring this up, you can basically just highlight the name of the hole loading pattern in the UI. And if I wanted to increase this, say, to 75 pounds, I can do that. And you notice that it pushes everything up, and it basically trims things off from the bottom. Get that to re. And so what ends up happening is that this top has now exceeded the overall 100-foot depth. And so the one thing that you can do is you can remove a material, and we always add and remove from the top. So we load from the bottom, but as you add and remove material, we basically build it up from the bottom And so if you remove a material, it's going to remove the topmost guy. And if I hit add material, it's going to recalculate that actual depth of that top stemming for me. So that's pretty much it on hole loadings and blast patterns. And obviously you can do any combination of these guys, of materials in here. And you can see that we generate a nice little legend here off to the side to let you know which color indicates the various blasting materials. So what I'm going to do now is I'm going to lay out a blast pattern. So I have this nice bench with a simulated seam down below, and I'm going to create a blast pattern. It asks me what the top surface is, and that's the blast pattern small. That is my top. The second surface is going to be my stratified grid, which I've already got loaded. If it's not loaded, you can go ahead and load them both from a file. You can also create that second surface based on a fixed elevation. So if we wanted to drill to exactly 800 foot in depth to that specific elevation, you can specify that. If you want to do a depth from the surface, so if you want to drill exactly 50 feet from the top of the surface, you can also specify that as well. And now what I'm going to do is pick my boundary polyline. And if you use CARLSON Office mining plan tools, you can import these blast polys as PLNs from the CARLSON product. And what that allows you to do is do your mine planning in our Office product, and then import your blast polylines into P3D drill and blast, so that you can do your design pattern in 3D, set up your hole loadings, export it to GRL, bring the drill hole data, the as drilled data back in to P3D, and verify that your drill holes are within tolerance, and if they're not, adjust your hole loadings accordingly. So here we're going to edit the high wall. So the second prompt after I draw my boundary polyline, and what you want to do is typically draw down down to your toe on the bench. What I'm going to do is simplify this. So we do a best fit, and we try to auto-identify this high wall for you. But sometimes what can happen is we get odd results at times. And so if you want to really straighten that out, what I'm going to do is I'm going to do a replace polyline section. And I'm going to select this point where it's straight here. Now you can, and since this goes up just a little bit, what I can do is I could still put a little jig in here, but I can pick multiple points along here. And then if I actually click on the polyline when it's highlighted yellow, then it's going to finish the command. But I don't want it to finish here. I want it to be nice and straight right up to this edge. And so now you can see that we've auto delineated a high wall for you, given a good first guess, and then we've given you a tool to go in and really straighten that out. And I'm going to press the right mouse or the enter key to complete that action. And now what it's asking me is, what do I want my blast pattern to be like? So do I want it to be staggered or rectangular? What's the blast pattern row direction? And I want to use my nearest snap because I want to have it. I want it to be nice and straight and follow this back polyline. So I'm going to pick exactly nearest on these guys. And then based on your 10-foot offset and the settings that we had, we'll give you additional snaps so that you can snap to this 10-foot, 5-foot offset. Basically 10 foot from the high wall. So we're drawing you this blue polyline that sort of shows that 10-foot offset. And then we're also showing a green polyline, which is the blast pattern offset. It can be 0 if you don't want any offset at all, but I'm just going to go ahead and select in here. And now what you'll notice is that we've laid out our blast patterns, and I can turn on the whole text. So here you can see we have um, our our A row, and then we have our 1 column, our 2 column, 3 columns. So basically we're using the letters for the rows and numbers for the columns. And your default display value, you notice that these holes have different colors. I'm going to turn on backface culling here so it's a little clearer. But you'll notice, especially in this front row, we have these tolerances set. And what we're doing is, in your blast holes, we're showing you the high wall distance display. And so basically what this means is that in your high wall, so our minimum high wall tolerance for this is 10 feet. So we want it to be at least 10 feet from the high wall, which they all are. They're green, except for there's some red spots down there I can see, and I'll show you how to fix that. And then the maximum high wall tolerance is 30 feet. So you don't want it too close, and you don't want it too far away. So basically, you tell us what these are, and we'll show you these graduations of colors. So in this case, what it's telling you is green is more than 10 feet away. Blue is halfway, is basically 15 feet. And this orange is more than 20 feet, but less than 30. So effectively, what we're showing you here is all the way, as measured all the way down to the underside of this surface, we're showing you how close these guys are. And in this case, you may actually want to have a dip angle set on that first row. And to set a dip angle, all I'm going to do is go over to my Scene Explorer, and I'm going to select row 1. And I am going to set the dip angle to let's try 35 degrees. And you notice 35 degrees obviously pokes out the side. You're getting red indicators down here, and obviously it's too steep. So I'll pull that back to a 25 degree. And again, now what you're seeing down along in here is we're showing you that you're still within your 10 feet, but there's still some blue spots where you're almost half the distance away from that particular point. So you can see there's a little bulge here, and as we project this straight out, there's a little bit more distance covered right in here. But again, we'll give you that visual indication. So if you need to modify your hole loadings for these particular holes, you can do that. And on row 2, you may actually want to set a slight dip angle on that as well. So basically, you can select the blast holes, select a dip angle for all of them, select a row and change the dip angle for every single one of them. If I wanted to change the dip angle for just a single hole, so I'll select this first hole here and call that 25. You can see just that one hole is modified. I'll put it back to 10. The other thing that is typically done is you may want to have a pre-split here on this back row that we've got nice and straight. So I'm going to pick that back row, and I'm going to change the hole diameter to 4 inches, and I'm going to change the hole spacing to 10 feet. So now basically what you have is you've got your pre-split row, and you can see that we're updating the Voronoi diagram for the top and the bottom of the drill surface as you make these modifications and changes. We do have a few other tools that are kind of nifty. So I mentioned that we had some red going on over here. So I can also take this top surface and I can make it transparent, which allows you to see that this A16, A15, these holes are a little bit too close. Well, they're actually inside of the high wall. And so if you've gone to the effort of identifying and drawing out your nice high wall, that you want your drill pattern to follow. We have another command that's called adjust drill hole high wall distance. And what this will do is, this is a command that will allow you to specify the distance that you want, that your minimum distance setback from the high wall. And it also let you specify the last straight row. And in this case, we would typically want that to be G, but so basically we're going to adjust this high wall, and as you can see, we've actually already done it. So right now these holes are 10 feet back, and we're saying the straight row is row 2. So you can see that row 2 has not moved. It hasn't adjusted with the pattern. But what I'm going to do is say, well, okay, this is my row 1, 2, 3, 4, 5. So I want to make adjustments until I get to row 5. So the last straight row I'm going to put as 5. And then we're going to make all those adjustments for you, so that now your holes are all a minimum of 10 feet from the high wall. And the one thing that aligned to high wall did was it actually added in a couple more holes than we had before on that front row. Notice that they don't have the same dip angle. That's easily corrected. I'm going to press enter to accept this new layout now that I have my perfect 10-foot setback. And what I'm going to do is I'm going to highlight this row again, this row 1, and I'm going to set my dip angle back to 25. So that we get a nice consistent dip angle for that row 1. And on the blast boundary, if you want to find out what the elevations are on the corners, let's see, the blast. We could do that for a report, but what I'm going to show you now is how to do the hole loading. So I'm going to select all the blast holes, and I'm going to go to my hole loading tooltip, and I'm going to load a loading pattern, and I'm going to pick this 100-foot typical, and I'm going to hit OK, and then I'm going to put my display for my blast holes into hole loading mode. And you notice right away that we have a problem, and that problem is more than likely these holes are not very deep. Oh no, they're actually really deep. So we have 178-foot typical hole depth. And so what we need to do is adjust our loading pattern. And so I'm going to rename this to 200-foot typical. I'm going to set the depth to 200. And I'm going to adjust I'm going to remove this material, and I'm going to remove that guy. And for our 200-foot depth, I'm going to start out with a 100-pound charge. And then I'm going to add basically 3 decks in here. So we'll go 80 feet of drill castings. We'll add another material, which is going to be Ampho, a 75-pound charge. I'm going to add another 50 feet of drill castings, and then a smaller charge of Ampho, and then I'm going to fill the rest with the drill castings. And again, you can change the thickness of these guys if you want it to be specifically 3 feet of AMFO. But more typically, you're just going to want to type in these even values of your weights. And I'm going to pick OK. And what that's going to do is apply that hole loading to the hole that I had selected. So you can see that this hole A1 is the one that I had selected. Now it's got the 3 decks, and it's showing you where they are in the scene. So what I want to actually do is I'm going to pick all the blast holes. I'm going to click on hole loading. I'm going to pick the 200. And now they all have that same hole loading. But you go, well, I've got my pre-splits in the back. My pre-splits, I want to have air. I want them to be empty. So now how do hole loadings get applied to as drilled holes? Well, we do have since I don't have an active drill machine here to go out and actually drill this plan out for me, what I'm going to do is use a tool that we have to simulate the drill hole experience, so I can show you how this gets applied. So I'm going to go and pick my projects test drill. What simulate does is we take your current pattern, we export it, and then we put minor differences in there to simulate minor differences in your drill hole. I'm going to pick that same file, and I'm going to import the blast pattern. So here I'm picking a DRL, but you can also import a CSV file, and then specify the which columns are the collar and the bottom coordinates. And I'm going to pick OK. Now this is the effect of simulating the import and having some of these values out of tolerance. Right away that you can see, we create a new folder, and it's based on the time and date stamp of the file and the name of the file that you imported. And what we're going to do is show you every single one of these guys that has a violation. So if there's a single violation of your tolerance, it's going to pop up on the row. Then all you have to do is expand that, and you can get the details on which one of those holes is violating the tolerance value. And more than likely, these are dip angle. Now this is collar error because we're 1.6 feet out on the collar error. So essentially, once you import these guys, you can't edit the geometry of these as drilled guys, but what you can do is I'm going to turn off my design drill holes, and I'm going to put these guys back into hole loading mode. And what we do is we transfer your design hole loading to your as drilled holes when you bring them in, and we also maintain the same text as the same IDs as well. And again, what you're going to see here is if I pick on this hole here, we're going to see the details, and it's basically a 4-foot bust on our collar drill. So if your dip angle is out of tolerance, if you want to change these, so for example, if I set this distance tolerance to 3 feet, the dip angle to 5 degrees, you notice that an awful lot of the errors went away because it's within tolerance. So this is just a visual indication to tell you that something is out of tolerance, and it's something that you probably should take a look at before you actually load the holes and blast. And now I guess I could show you the reports. So the blast hole report, basically, I'm just going to remove all this and then select everything we have to load, which is basically the hole IDs. And we export to a format where we put the units of measure in on the column headers, and we don't put in any units for the numeric value so that you can import this into an Excel spreadsheet very directly, and in order to compute any other things or to generate other reports. But you can see that we give you your weight in pounds and the volume and the thickness for each one of the decks. We also will give you the, let's see, I think we give you, trying to find back over here, not on this report. I want to show my totals. So we'll also sum up appropriate totals. So in this case, we have the whole length total. Will also sum up the deck thicknesses and weights for you as well in those columns. Then you can basically save this to a file, export it, create an HTML report, or export to Microsoft Excel. Here's your report in Microsoft Excel. And again, we have the totals identified down there as well. That is our design drill report. We also have a as drilled report. The as drilled report adds all of the errors for the dip angle, the azimuth, the surface coordinates, and the bottom coordinates. You can go ahead and add those to your report and display those. And now what we're going to tell you is what the error values are. So you can print this report back out, and you can go down the list of these errors and certainly highlight any of the ones that were out of tolerance, like we do in the graphics environment to prepare your report. So that's pretty much it for an introduction and a kind of a quick setup and getting to know CARLSON Precision 3D Drill and Blast 2016. Thank you.